Alright, good afternoon, I guess. It's 3 o'clock-ish here. Just looking at a couple different applications of UT. We've got a Bondmaster here. This is an Olympus phased array scope, an OmniScan, and then there on the end we're going to get into just basic pulse echo. With Bondmaster stuff, which when we get into actual Bondmaster working, we'll be looking at some of these panels. But if you look back here, let me pull this up here so you can see it. We've got Bondmaster panel or a bonded panel. Okay, got some glue back here, resin, adhesive, whatever you want to call it. And then some spot faces back here. When we get into Bondmaster or Bondmaster testing, I guess, bond testing, we're going to be looking at the differences between what this thickness looks like versus this thickness with the glue and the spot faces and all that. So, a little bit of bond testing. We've got a Bondmaster 1000 E Plus here. Got a little resonance probe to go with it. You guys have read a little bit about resonance. Okay, you got a little 165 kilohertz here, or sorry, this guy's 110 kilohertz. Low frequency. Okay, this is actually in the sonic range. Well, it's still in the ultrasonic range, but it's outside of what we generally do ultrasound with. So, not a huge problem there. Little couplet. We've got a pitch catch transducer right here. Okay, when we get into bond testing again, this will be a little pitch catch transducer that we're going to use. And then just some stuff that we can test. Piece of composite, a little reference standard that we got. This is a NavShips block, a NavC block. This is a resolution block that we get into when we get into actual calibration. Then we also have another little DC block here, which is just distance. Okay? A couple radiuses here so we have some common ground on distance. 1-inch radius, 2-inch radius. Okay? Then just our standard bottle couplet. There's our phased array scope. Okay, we worked with that one last time. We'll just jump here down to a regular scope. Okay. Once we get all zoomed in here, you're looking at a 3-inch range, meaning just 3 inches of material that we're going to inspect. This velocity from your reference data sheet is 232,000 roughly. If we go to a standard velocity, 233, that's what you're used to seeing on your reference data sheet. Probe delay down here, display delay up here. I'm going to take both of these back to 0. That way that kind of gives us our starting point. Alright, so we got a 3-inch range. There's our plain old steel, compressional velocity, display delay, probe delay. So, if we just kind of look through some of these menus here, we got a base menu, pulsar menu, that's going to tell us how we're going to drive the transducer, low damping, low power, single mode since it says dual off, and this PRF mode is a pulse rep, basically a pulse rep refresher rate of the screen here. See how it's kind of jerky down here now. We roll that up to 10. We got a lot of stuff happening here. So it's more of a real-time inspection. Okay, plain old transducer, single element. This is a 2.25 megahertz, half-inch diameter. Shear wave transducer right here. Okay, and we know it's a shear wave because it's got an angled wedge. And then with compressional transducer, we slap on there to make sure we can turn that into a shear wave, refract that into a shear wave. Then just another transducer here, just for fun, is a delay line transducer. There's just the edge of the transducer, put a little coupling on there. Here's the delay line right here, just a little piece of lucite, plexiglass, plastic, whatever you want to call it. Okay, we tie that on there, make sure it's tight. And then last kind of transducer is a dual element transducer. Got a nice clean line down through there, crosstalk barrier, so this crystal can't talk to this crystal over here. Okay? We know it's dual element, it's got 2 hookups. So, just a little bit about that. Let's go with a single element transducer first on a 3-inch range. Just going to hook in B and C connection, microdot connection. You might see questions floating around that say, which of the following is most common ends, B and C microdot? So those are out there. There's our B and C hookup. Here's our microdot hookup. If you see a bunch of spiking right there, that's telling us that the transducer is alive. So we hook that up. Okay. We've got about 45 dB here. We're going to roll this down to about 30. 25, I guess. Take our 1-inch step block. We got 1 inch, 3/4, a half, and then a quarter. Put a little coupling on there. On the 1 inch, we're just going to see what happens here. Okay? Got a little problem with my transducer cable. That's okay. So let's roll that up. We're on 3-inch, or we were, let's go back there. 3-inch range, there's our velocity, probe delay, display delay right there. So we want to set this up to where we have, on a 1-inch block, we have a signal coming up at 33%, 66, and 99. Like I said, I got problems with the cable here, so I'm going to have to get a new cable. That's okay. Alright, so 33, 66, 99. We're not quite there, so just for fun, let's roll this out to 4 inches. That'll make it a little easier numbers to mess with. 25, 50, 75, 100. So now we know we need 25%, a 50%, a 75, and 100. Okay? So we'll just look here. Say I got issues. Some people would say I have more than just those issues. Okay, so let's give it a little more gas. 25, 50, we're getting close to 75 and 100. Let's just take our velocity here and just move it around to see what we see. Looks like about 233. Looks like we're losing a lot of energy there. So let's go receiver. See if we can clean that up a little bit. That's a little better. Okay. So here's our 25, here's our 50, 75's right here, and our 100's pretty much burn up over here. This is kind of reflections inside the block, kind of bouncing back from the near field, just some general junk. So 25%, we're looking pretty close. 50%, we're pretty much right on the money. 75%, not so pretty. 100%, not so pretty either. So let's go to a little bit prettier block. Let's go to another 1-inch block here. Okay, that cleans it up a lot. 25, 50, 75, 100. Okay, still not all that pretty, so let's give it a little gain. Makes the signals a little more ganglier, but now we have some clear definitions. 25, 50, 75, and we're right on 100. So we can say that's calibrated. So if we go to a 4-inch block, now I'm moving a bunch of stuff around here. If we go to a 4-inch block, slap a little coupling on it, we have a signal come right up at 4 inches because we represent 0 inches all the way out to 4 inches. Okay, there's a velocity of our material, and we're pretty close. And when we go to a 1-inch side again, there they come right back up, 25, 50, 75, 100. Good with that? Give you a second to kind of let that soak in. All right.